Good evening, all of you. Good evening. Once again. Now we are going to discuss the Unit 4 of Professional Ethics in Engineering, that is the safety, responsibility, and rights. This is our syllabus of Unit 4. First topic safety and risk. The second topic is assessment of safety and risk. And next topic is safety benefit analysis and reducing risk. Fourth topic is respect for authority. And fifth one is collective bargaining. Sixth one is confidentiality. And next one is conflicts of interest. Eighth one is occupational crime. And ninth one is professional rights. 10th one is employee rights. And next one is intellectual property rights and lost discrimination. These are all the syllabus for Unit 4 of safety, responsibilities, and rights. Next, we will move to the topic, what is safety and what is risk? Safety was defined as the risk that is known and judged as acceptable. But a risk is a potential that something unwanted and harmful may occur. It is the result of an unsafe situation, sometimes anticipated during its use. Probability of safety equal to 1 minus probability of risk. Risk is equal to probability of occurrence in consequence in magnitude. Different methods are available to determine the risk. Testing for safety. Testing on the functioning of the safety system components. Destructive testing. In this approach, testing is done till the component fails. It is too expensive, but very realistic and useful. Next one is prototype testing. In this approach, the testing is done on the proportional scale model with all given components fixed in the system. Dimensional analysis could be tested to project the results at the actual conditions. Simulation testing with the help of computer is used. Next, safety must be an integral part of any engineering design. In other words, of William W. Lawrence, a thing is safe is its risk or justified to be acceptable. So a design or thing is said to be safe. If for the person who judges, the perceived risk is high. In short, safety means an acceptable risk. But the drawbacks of definitions of Lawrence are underestimation of risk, overestimation of risk, no estimation of risk. A modified version of Lawrence definitions is a thing is safe if that it is risk-free known. Those risks would be judged acceptable in light of settled principles. More fully, a thing is safe to a certain degree with respect to the given person or group at a given time if were they fully aware of its risk and expression their most settled value. They would judge those risks to be acceptable to that certain degree. The difficulties in Lawrence definitions are overcome by knowledge and settled value principles help to rule out the irrelevant judgments. Safety is frequently taught in terms of degrees and comparisons. The degree to which a person or a group, judging on the basis of their settled value, would be decided that the risk of something or more or less acceptable in comparison with the risk of some other thing. We interpret things to include products as well as services. Next one is risk. When a thing or a product is proved to be a dangerous or hazardous, then it is unsafe. A risk is potential that something unwanted and harmful may occur. A risk is a possibility of suffering, harm, or loss. Risk is defined as the probability of a specified level of hazardous consequences being realized. A risk is a product of probability and consequences. Risk is denoted by the letter O and consequences denoted by the letter C, which is given by the equation risk is equal to probability, the product of probability and consequences. The risk is defined as the probability of specified level of hazardous consequences being realized. On the basis of technology, risk includes the dangers of bodily harms or economic loss or environmental degradation. Good engineering practice has always been concerned with safety. Whenever the society is more influenced by the technology, there is more possibility of facing risk, not only by the users, but also the users. It causes ecological imbalance. So safety demand will be higher. A risk may fall into one of the following categories. Low consequences or low probability can be ignored. High consequences, high probability. Low consequences and high probability. High consequences and low probability. Obviously, we need to concentrate on the third and fourth categories of risk, which is high consequences and high probability, low consequences and high probability. The third category of events, the so-called learning indicates, is precursor to high consequences of major events. The fourth category comes under the major hazards control and requires special attention. The risk analysis is mandatory for this category of major events. A disaster is equal to a serious continued event, a state of unpreparedness. Next one is acceptability of risk. William B. Rowe says a risk is unacceptable when those affected are generally no longer not apprehensive about it. Doubtfulness depends mainly on how the people take the risk or how people perceive it. This perception of risk is mostly influenced by the following factors. First one is voluntarism and control. Second one. Second one is effect of information on risk assessment. Third one is job-related risk or job-related pressures. Example, working in the steel plant or chemical plant. Next, we are going to discuss assessment of safety and risk. It is a very difficult to attain 100% absolute safety in an engineering product. If there is any improvement in safety, it often goes with an increase in the cost of the product. On other side, the products which are not safe always increase in the secondary cost of the producers, such as warranty expenses, loss of customers, goodwill, and downtime in the production process, etc. An engineer must know the safety measures before assessing a risk of any product. The practice may be like, does the engineer have the right data? Is he satisfied with the present design? How does he test the safety of a product? And how does he measure and weigh the risk with benefits for the product? A stress on high safety and low risk leads to high primary cost and low secondary cost of the license. Next, we will discuss knowledge of risk. It is the data in designing a product. Thought, though past experience and historical data give better information about the safety of product design. It is small, inadequate. The reasons for the inadequacies are the importance is not freely shared among industries, and there are also new applications of new technologies that provide available data which are less useful. Uncertainties in design. The risk in a product arise due to so many uncertainties faced by all kinds of engineers, such as the design engineer, the manufacturing engineer, and also the sales and the application engineer. This is also the knowledge required to assess the risk of the product. So, in order to minimize the risk involved in any product and engineering, an engineer has to investigate the following criteria. That are purpose of redesigning. The purpose of redesigning a product has a lot of uncertainties in the test design itself. Application of the product and materials and the skill used for the product, producing the product. So next, we will discuss safety for testing for safety. Safety and risk analysis also. Recent occurrences of large-scale accidents in which many lives were lost or in which great damage was caused due to the environment has led to more attention being paid to safety within industrial plants or installations. As a result of this attention, risk analysis techniques have come to play an ever increasing role. Risk reduction can take place or different levels wise in implementing the inherent safety provisions during the redesigning stage, applying safety measures, preventing or limiting damages, providing safety zones around industrial plants, and by the emergency planning. Next, next we will discuss risk analysis. Risk analysis is used for assessment of the hazard associated with an industrial or commercial activity and can be summarized by three questions given below. One is what can go wrong, which is identification of hazards. Second one is what are the effects of consequences, which is analysis of consequences. And next one is how often it will happen. This is estimation of the probability. These are all the three cousins of risk analysis. In next class, we will discuss analytical methods.